Hey guys, welcome to this video. In this video, we'll talk about evaluation metrics that are used in classification machine learning algorithm. So we know that in machine learning algorithm, there are majorly two types of machine learning algorithm. One are your classification algorithms, other one are your regression algorithm. They are other one as well. But when you talk about specifically supervised machine learning, you have these two categories. You have your classification algorithms and you have your regression algorithm. Now, there's a concept of evaluation metrics. Evaluation metrics, as the term suggests, that it helps you evaluate how well your model performed. You know, how will you else judge, okay, whatever training you have done, whatever your model has learned in machine learning. When we say about machine learning, so basically your machine is learning something. So to judge that machine learning is the evaluation, right? And in this video, we'll specifically talk about classification evaluation metrics, and there are several of them. There are specific cases when we use them, you know, and then some rules as well, and then some formulas as well. We'll go through all of them, and yeah, let's dive into the video. So when I talk about classification problem, so let's just see how a classification problem looks, right? Because it will be a good context for our video head. So when I talk about classification problem basically is something like I have particular models, okay, and what I want to do, just let me check if sound is getting recorded. Yeah, so yeah, I have in my data, I'll have a dependent and independent variable. So I'll have dependent variable and I have independent variable. Independent variable. Dependent variable is that particular feature or that particular column that you want to classify. Let's say I have a credit card data and I want to classify my customers into two segments, either a premium holders or general holders, right? So premium holders will be customers if you talk about business point of view. So premium holders will be customers who have who have big spending on their credit cards. You know, they use their credit cards a lot and you want to give them benefits. Now those benefit could be the credit the airport lounge, or you want to give them special discount on flights, you know, those kind of stuff. And then the other one is your regular user, someone, you know, like us, I would say. So in that particular case, I have my dependent variable as a binary classification, right? So it will be either 0 or 1. Okay, so 0 basically means that it's my primary kind of a user, and 1 basically means that primary or normal, you can say. Okay, 1 basically means that it's my premium user. Cool. This is my dependent variable. Now independent variables are the other variables on the basis of which we will train our machine learning algorithm, right? So this could be anything. This could be multiple data that is associated with credit cards, something like your credit score, right? Something like your spend, you know, average monthly spend, you know, your credit limit, right? These all parameters come as an independent variable. Now this is a problem statement. Let's say I applied a machine algorithm. Let's say I applied a DC entry classifier here and I got my results and I am finally done. Now when it's come to evaluation of problem, I have a classification report and I have a confusion matrix, right? Let's see them one by one. First, let's see confusion matrix. So confusion matrix basically says that, okay, when you're taking an example of simple binary classifier, okay, taking example of simple binary classifier, you say, okay, there's an actual values, okay, what they were supposed to do. Actual value basically what was the actual value of that data. Let's say there were 0 and 1. There were two kind of actual values of the data. Okay, just be with me guys here, and here is my predicted value. Okay, now this predicted value, let's say they are 0 and this is 1. Now what does this mean? This basically on this axis, I would say this axis, I have my actual values. Okay, actually it was 0 and actually it was 1, the two scenarios. And in this axis I have my predicted values. Okay, predicted, what I predicted or my model predicted it as 0 and my model predicted it as 1. So there are two different scenarios. So what does this particular segment, this particular part mean, guys? If I just talk about this first quadrant, this basically means that actually the thing was 0 and you predicted it as 0, right? So this becomes my true negative. Just type it, true negative. you can just remember it like true negative, something like because it's zero, so you can call it negative. But when you talk about negative and positive, that goes more into idea of null hypothesis and hypothesis testing and type 1 and type 2 error that we'll also talk about. So but in general it was identified as 0, which I am taking negative here, and is truly predicted as 0, so it's true negative. Okay, so if I'll write it, this one becomes my true negative. Similarly the other one, this one guys, the fourth quadrant, this was actually predicted as 1, and then one actually classified as 1 as well. Okay, so this becomes my true positive, truly qualified as positive. It was qualified as, it was predicted as positive, and it was true that it was positive. So break these terms guys, because these are quite confusing terms, true negative, true positive, right? These are quite confusing terms. Break this part, negative and positive. This is the second part, is my predicted part, and true and false is coming from my actual part. So actually it was true and I correctly predicted, sorry, actually it was like, it is like whether you judged correctly or not. So actually it was negative and it was predicted as negative, that is a true negative. Actually it was positive and it was predicted as positive, then that's why it's true positive. Similarly, if you can just assume what will come here in this part, so this is basically my predicted part is 0, so this is negative, predicted as negative. Is it correctly predicted as negative? No, this is falsely predicted as negative, right? Because it is supposed to be positive, because the actual value is 1, right? So this is my false positive. Let me write it in black so that we can see it properly. This is my false positive. And in similar case, this one, what happened in this particular case, sorry, this one would be my false negative actually, yeah, because it was predicted as negative and it was falsely predicted as negative. This one would be my false positive, final one, because actually, again break it guys, when I am saying false positive, what does false positive means? That last one is predicted, so it was positive, predicted as positive, so it comes here, here or here. Now whether it's predicted correctly or not, no, we are saying it is falsely positive, that means it was actually negative, and actually negative is 0, so it comes here, false positive. So these terms, true negative, false positive, false negative and true positive, they together form multiple metric that you can evaluate basis on what particular thing is important in what particular case, right? Now you would be thinking, how can it be differentiated, at what particular thing is different? Like, let's take an example. First let's decide on what particular basis are we trying to differentiate them, and how those bases are really important business cases, right? What can be different use cases. Let's just see a simple example of health test. Let's say I have built a machine learning model that detects cancer, okay, and in that, if it's predicted as 0, that means I am safe, like you don't have cancer, and if it predicted as 1, that means you are prone to have cancer, or like you are at risk of having cancer. So what we'll do in that particular case is just try to think it in more business aspect guys. So if somebody has a cancer or more this fatal disease kind of a thing, where it's quite a high risk thing, okay, so even if you have a 10% chance of getting cancer, or if you have a 90% chance of getting cancer, even a 5% chance of getting cancer, I'll give you a suggestion that you are prone to get a cancer, okay. That is the thought that we have while deciding these things, okay. So when it comes to this particular part, actually was 1, right? So in this particular case, when we are predicting cancer and we have things like here, so again I'll divide it. So this part basically, this part is where actually you had cancer, right? So now these your true positive, false negative and true positives becomes really important. Why? Because in case, what was this one guys, this was your false negative and this was your true positive. Both of these cases were actually true positive, so it's not actually prone to have cancer, right? So now what I want my machine learning model is out of those cases which were actually having cancer, how many were you able to identify? Because those are really important in this particular case. This is the use case that I want you to understand properly, that on the basis of different industries, on the basis of different use cases, your metric will change, and this is the idea that it change. Okay, and let me tell you how will it fill. Let's say I have 100 data points to classify. So out of those 100 data point, it will get classified something like this. So 100 data point, 20 will come here, 25 would come here, right? 60 let's say come here. No, not 60, let's say 40 comes here. Okay, and how much is remaining? 60, and this becomes 85, and 15 comes here. Okay, so these 25 and 15, what is 25 plus 15? 25 plus 15 is your 40. These 40 cases are where you actually had cancer. Okay, and out of those 40 cases, I was able to identify 15 cases. Okay, so my whole idea of judging my model comes down to this ki, hey, I don't care about those cases where you didn't had cancer, right? I care about those cases where you actually had cancer, and how many of them were you able to identify. Okay, because those are important. If we miss those cases where we didn't had cancer, whether we able to classify as positive or negative, that is not that big a deal, right? If my report comes out, let's not take my example, let's take our enemy's example. So if my enemy's report comes out, and there is a chance that it's given that you might be prone to cancer, and your report is false, right? Still, right, if there is a problem in that, that's okay, because if in case that was true, you were prone to cancer, which is kind of a fatal disease, right? So I hope you got an idea, guys, that based on a different approaches, based on a different use cases, the things are different. Now, considering these thoughts that I've just shared, we can form multiple matrix out of this one confusion matrix. So this is basically a confusion matrix. If somebody asks you what is confusion matrix, you have to draw this thing, and you have to tell them ki these four are the cases and what is the actual predicted value. Now let's first talk about the biggest problem in like most common term that we talk about when you do evaluation metric, when we talk about evaluation of your machine learning model, and that is accuracy. So the first metric that we'll talk about is accuracy. Accuracy is nothing, guys, it's simple. Again, just list, take a confusion matrix in account, 0 1 0 1. Okay, this was your actual, this was your predicted. Okay, so these were truly positive, these were truly negative, right? And these were false negative, and these were your false positive. Okay, fine. When it comes to accuracy just said ki, okay, tell me how many of them were you able to classify them properly, and just divide it by all the numbers, right? So your accuracy will become your true negative plus true positive upon false positive plus false negative plus true negative plus true positive. This is n. Okay, so it's just like how many were you able to classify correctly, whether it was 0 or 1, divided by all the numbers. That is your accuracy. Cool. And this is like the most general thing. If you have a balanced data set, guys, most important thing to remember that if you have a balanced data set, you favor accuracy. If you have a balanced data set, you favor accuracy, because that is a correct metric to judge in that particular case. Then next thing we have is recall. Recall basically just is similar to what we did in health case, right? The cancer detection case. So in those particular cases, what we do, we take only the actual one value, and we say how many of them were you able to classify. So I'll say, yeah, it will be true positive divided by false negative plus true positive. This was my recall, and you can remember it like this, that it's recalling out of the actual corrected value, how many of them were you able to classify. Actually one value was this, how many were you able to classify? These were the ones. True positive upon total value, false negative plus true positive. That is your recall. Next thing is your precision. Precision, let's look at a formula first. Precision basically it's a bit different. It's basically how precise your model is, right? So now we are not talking about actual thing, we are just talking about the precision of your model. So we are just concerned about what your model predicted as 1. Okay, so we were able to classify these all as 1, and how many of them were correctly classified? True positive upon true positive plus false positive. So when we talk about precision, we talk about precision of your model, and precision of your model becomes, okay, out of what your model was able to classify at 1, how many of them were correct. Recall basically recalls from the original statement that out of all those which are actually 1, how many of them were you able to classify. Cool. So these 3 metrics are the most common metrics: precision, recall, and accuracy. Now comes one more, which is quite simple one, but not that much of used, which is your F1 score. Okay, and F1 score comes from the idea of F beta score. Okay, so F beta score is a big form. It's not that big a formula actually. I think it's 1 plus beta square upon precision recall, right? So this will be like precision recall upon precision plus recall, and I think beta comes here as well. Yeah, if I'm not wrong, this is the formula for F beta score, and if you put beta's value 1 here, so this will come as 2 precision recall upon precision plus recall. And if you can understand this properly, this is nothing but harmonic mean, right? You have different means in mathematics, right? If you guys remember arithmetic mean, geometric mean, there was one harmonic mean that we didn't study it properly. So precision F1 score is basically your harmonic mean of precision is recall. It is not that much of a use. It's basically, you can say, gives you a mixture of precision recall both. Okay, so now I'll give you a general use case in what case which metric you have to use. So when you're talking about something where your actual value does not matter much, and it all matters ki how many of like, if you misclassify something, that is not that big a issue. Okay, in those particular cases, if you misclassify something, if it's not that big a issue, you choose recall. Sorry, you use precision. In cases, for example, spam classification, when you have emails in your folder or in your Gmail account and those are classified as spam by Gmail, you will see a mark over those emails, yeah, this is suspected to be a spam, right? So in those cases, even if you misclassify a email, it's not that big a deal. You're just misclassifying an email to a spam, and it's not that big a deal. It won't change the world for you, right? So in those cases, we use precision because we are just concerned about how precise our model is. Okay, and we are not that concerned about that if you misclassify a point, what will be the precaution of it. In case of healthcare or in case of finance, let's say you are doing application of credit card risk, right? In those cases as well, you will go for recall. Why? Because in those cases your data set is highly imbalanced, right? When you do something like transaction fraud data, right, in those cases very less of the transaction are actually fraudulent transaction, right? So when you have an imbalanced data set, in those particular cases you use recall. When you have a balanced data set and you don't know much about what you don't concern much about misclassifying a thing, right? Both of things are equally okay for you, just want your model to predict everything, right? You go for accuracy. And let's say you are confused between precision recall, in that case you used your F1 score. So these were the 4 general metric, guys. So I've been doing this series quite a lot, right, where I don't put any documentation. I just open a blank sheet, I discuss the knowledge, discuss the ideas in a raw format from scratch. So but I got some queries, okay, it will be helpful for us if you have a documentation as well or some notes as well. So I just created a presentation out of what I have done, right? Whatever I have said, whatever I have taught in this, those all things are documented in the presentation. I'll share the presentation along with the video description here, so you can check that out. You can keep that as a note, and also you can share the video, comment on the video, like the video, and subscribe to my channel. I've been doing this series of putting fundamentals of data science out there as a raw thought, just open discussions freely, right? There's no documentation, nothing. I just want you to sit back and understand these topics, because these are the beautiful topics. We are connecting maths to coding to statistics to actually business, right? And that's a beautiful journey. Yeah, my name is Shubhangi Survey. I'm currently working at Worldwide Technology as a machine learning engineer. I've been data scientist. I've worked as a data analyst as well. You can follow me on LinkedIn or Instagram. And yeah, happy learning.